Yeah, hello. Good day, everyone. Today we're looking at how to create a decentralized application, just a mini decentralized application. But firstly, we'll be focusing on the smart contract part. So aside from how to create a decentralized application, we'll also be looking at a module called Web3. This module is used to integrate our client's application with our smart contracts with the help of the ABI. So let's head down to their documentation. Yeah, this is it. So basically, this is our API reference, or should I say the just documentation. So basically, this is a Web3 documentation. So anything that is needed about Web3 is available here. So basically, it's Web3 is just a collection of libraries that allow you to interact with local or remote Ethereum node. So when we say local or remote Ethereum node, these are our smart contracts that we've uploaded or that we've deployed to the blockchain or to our local blockchain. So when I say local blockchain, we'll be talking about let's say our Ganache, our blockchain on our system. When we say remote, this the available blockchain that we know, like Binance, Ethereum, and the likes. We have Solana and the likes. So that's it. So if you want to install this, let's open it. Yeah, so this is how to add our Web3 provider, our Web3 inside our application. So if you want to make use of npm install, you're free. If you want to make use of yarn, no problem. So you're gonna make use of npm install, your yarn install, and if you want to access the pure JS file, all you just have to do is navigate from web3/dist/web3.main.js. So back to our smart contract. Okay, sorry. Yeah, back to our smart contracts. We'll come back to this. Yeah, so here I have three tokens. Let me say two tokens. I'm very sure that we all know how to create an ERC20 token. Okay, let me just walk you guys through. So basically, this is a DAI token, which is just like a stable coin. This is a token that our user will own, that they will use to stake. So this is a DApp token. This is a reward token. So basically, you know that when you want to create an ERC20 token, you need to specify your license. It can be MIT or anything. After specify this pragma is also trying to tell Solidity in what version of Solidity the code will compiled. Personally, I like to extend my version so I don't have any problem. So right now, any version ranging from 0.4 to 0.9 will work. So instead of specifying, let's say, specifying this practically means only use 0.9. Well, you can also do this too. This would basically tell you that you should use 0.9 upward. So I like to, make use of range. So basically, we initiated or we declared the name of our smart contract, the symbol of our smart contract, our total supply. This is our decimal. So yeah, this is our decimal. So now this is an event. An event is just like a notification that is being fired whenever a transaction is carried out. Let's say user A make a transfer from our address to an address. So you're going to emit an event so that any third party application will be able to catch what was emitted, or what parameters was, was made use of. So let's look at this first event. It's called transfer. So this is going to return the address that the money was being transferred from to the address the money was being will be transferred to. This is also the value of address. So imagine a third party application connected or listening to this our smart contract. Whenever you create a smart contract, it will broadcast, it will emit an event. Then the application will, will pick the event and probably process it the way they want. So the same thing as approval. So balance of now, we know what balance of this. There's a need of this balance of why, just because we want to keep track of, or the balance of all addresses, or let me say all users. So here the balance of will take in the address, then will return the units. So imagine me saying I have a store that register my name, and they will give me the output of coin I have. So right now, if I put my address here, this the output will be 0. Why? Because I don't have any balance. So this allowance of now is made use is made use in the sense of another person trying to like spend your token. So this is how it works. Let's say you want to stake a token. So what does that mean? That means money will be moved from your token, or from your address to another person's address. So before that will be carried out, you need to approve the person that wants to remove the money. That okay, I approved you I approve you to remove $20 in my account. So don't worry, we'll get there. So this is basically a one-time function constructor which will run after we've deployed our smart contract. It only run once, just like a special function. So basically, our ERC20 token has 3 functions. You get. So this is the transfer function, this is the approve function, and this is the transfer from function. So let's start from the transfer from function. So what the transfer function does is, it's transfer money from an address. Yeah, it transfers money from an address. So let's see what we did now. Imagine me calling the transfer function now. So what do I check? Basically, you want to transfer money to somebody. That means from the message sender account to another person. So I will check if you have the amount you want to transfer in your wallet. If no, I will flash you an error. Okay, I think I can say insufficient balance. Permit me if I'm making spelling mistake. Yeah, so let's say we did insufficient balance. So this is just going to throw an error telling the person that called it why did you get the error? Because you have an insufficient balance. So after that, then basically always learn how to do one thing in smart contracts. Always tick before you give. So now imagine me, it might not really mean here, but when you are writing complex smart contracts, you have to take before you give. So imagine me right now, what I did was to deduct your balance before I even transfer your balance. Like before I even transfer upgrade the balance of the new address. It's just like all these our payment solution. Let's say Flutterwave. You see, those companies prefer that your money be with them. Imagine me transferring money from Flutterwave now to somebody and the transaction failed. It is certain that Flutterwave will have that money. The receiver might not get the money. So you then have to call the person that's you have to call the Flutterwave that I have a failed transaction, blah 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 blah. Imagine Flutterwave now calling all users that hello, our money is with you, blah 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 blah. It doesn't really make sense. So you take before you give. So when this line 31 decreases your account the message does enter account, and this increases the new address you want to send the money. It increases the account. Then you emit a transfer. So you emit an event. So same as approve. Now this approve is pertaining the mapping, the one I said on. It's just like sorry, I would I'll pause the video now and just go and charge here. So basically, approve function is just like for you to approve an address to spend your money. So this is allowance now. This message just enter is the person that wants to approve. This spender is the person you want them to spend your money. You get, so then you admit this approval. Yeah, so I think I've explained the approve function. So let's go to the transfer function. So this transfer function is helpful when asset will be transferred from an address to another address. Do you get? So now we first check the person calling the function. Do you have enough balance? That is line 44. Okay. If you pass that, then we check. Do you have enough approved balance? You know, I said the approve function will help the spender. Like the approve function will be done by the person that will be done by an address to approve another address to spend the money. So if you are not approved any money, it will fail. So if you pass the line 45, bravo, then you go to you do your normal mathematics, balance from, you deduct the balance from, then you increase the person's balance. So then the allowance, you reduce the allowance, you get, the person might not spend all your allowance, you get. So if it doesn't spend your allowance, then you put the new allowance. So then you emit a transfer and you return, let's say, a true value. Yeah, so yeah, this is just our DAI token. So our DAI token is pretty much the same as our DAP token. When you check it, the only difference is just the name and the symbol. The total supply is the same thing. So today, let's go to our smart contracts. This is basically a smart contract, just like a token firm smart contract, that allows user to stake token and to probably get reward, So basically, let's just look at it. Before we get access to that, we would, want to make use of our tokens inside our smart contract. So we imported sorry about that. We imported our two tokens, which is our DAI and DAP token. So we then create a token for a smart contract, which will be named token firm smart contract. You can name any of your smart contract, anything. So here, okay, we declared a variable called owner. It's private, just like the person that deployed the smart contracts. We get, so we also declared a variable called DAI token and DAP token. So okay, we also have an array of address which is called stakers. This is just to like store all addresses that are staked on this smart contract. We get, so oh sorry, for now we don't need this. It's a mistake. So we have these two mappings is just to like store users and staking balance, and the other one is just to like store if the person has staked or not. So like I said earlier, this constructor is a special function that runs only once after this thing has been deployed. Once it has been deployed, the constructor will I say cannot have access to it. So basically, we have three functions, which is called stake token, unstake token, and issue token. So let me just walk you through it. Now, remember I said you want to stake some tokens to get reward tokens, right? So basically, let's say you want to stake 5 tokens. I will first check, do you have that 5 token that you want to stake? Like, sorry, I will check if the token you want to stake is not less than 0. If it is less than 0, I'll show you amount. Amount should be greater than 0. Sorry about my spelling mistake. Yeah, so let's say, I said you would stake a DAI token, which is our stable coin, then you would get a DApp token. So now, once I have checked that, okay, you um you have an amount more than 0, no problem. Then I would make use of the transfer function. Now, I know some of you might be confused that why are we making use of a transfer function? Transfer function. Why don't we make use of transfer? Yes. So don't forget, transfer does not accept more than 2 parameters. Yes, it only accepts 2 parameters. Okay, so let's say I want to make use of transfer function now. Let's see. Listen. Transfer function takes the address that the money wants to go to and the amount. So imagine me using a transfer function and saying, okay, transfer money to smart contract address, the amount. Now, with this transfer function, we are not removing any money from the user's address. So that is why we can only make use of this transfer function. I don't know if you get what I'm saying now. So I hope that is clear. That's why we are making use of transfer from function. So before you can use this transfer from function, the user, the person calling this token, must have approved the smart contract. Imagine me not approving the smart contract and saying transfer from message on Zender to address, so to the smart contract address. This thing will fail. Before you can call this stake token, you must have called the DAI token dot approve, which will be done from the front end. I don't know if you get what I'm saying. So after you've approved the person, imagine you approving 10 naira, sorry, $10, very sorry, $10, and the amount here is 20. This will fail because you don't have to, you are not approved up to 20. So let's say this part is clear. Line 34 now, then we increase your staking balance. I know some of us might be thinking of doing this, like, at least this will work. Yes, practically this will work. But come to think of it, let's assume I want to stake again now. So I set this one to 50, right? And now I'm call this function again. Let's say I want to stake 20 again, making 70. Then instead of me doing 50 plus 70, I will save your staking balance as 20, which would be an error. So even if you not stake anything, this staking balance message to Zender will return your stuff to 0. So it will be 0 plus your amount. Then subsequent staking, it will now be like maybe 20 plus amount. I don't know if you get what I'm saying. So after that, then we'll set your status, which is as staked. Yes, have you staked? Yes. You get what I'm saying? So after that, we'll then save your address, which is called sticker.push message on Zender. You see, this message on Zender is the address of the person calling the function. It's not really anything. So on stake now. So our on stake function obviously will be a public function because we want people to call it out. So we first look for the person's balance, the person calling the address, calling the smart contract. What's your balance? You have 29 balance, 29 percent. Oh, sorry, you have 30 tokens. Then we'll check if the money you want to withdraw is greater than your balance. People are funny. I will have 10 naira and I want to withdraw 20 naira, which doesn't really make sense. So after I check, is the balance greater or equals to the amount to be withdrawn? If it is passed, no problem. So let's say I want to withdraw 10 out of 20. So my staking balance will now be balance minus the withdrawal amount. But let's assume I want to withdraw everything. It will now be 20 minus 20, which will be 0. So I'm practically saving my staking balance to 0. Then I would check if my staking balance is 0, right? If my staking balance is 0, I would say I will change your status, which is at stake. I will change it to false. Wow. Why? because you've unstaked everything. But if it is still greater than 0, you are still staking money. Now, this is where we make use of the transfer function. Why? Because we just want to transfer money to back to the person, back to the user, back to the user. So here, there's no need for you to approve anything. Why? Because nobody is spending anybody's token. They are basically collecting your money back from the smart contract. You get. So even if you want to use approve function, the smart contract will be the one to approve itself that, okay, but it doesn't really make sense. I hope you get what I'm saying. So we've explained the transfer, the stake and unstake token. So issue token now. If the user wants to call this issue token, sorry, I said user. The only person that can call this token is right now. Anybody can call this issue token, which doesn't really make sense. So basically, what I feel we should do is to check, require to check if. Oh, sorry about that. To check if message msg.zender. Sorry, I've been saying I'm sorry. msg.zender is equal to the person that deployed the smart contract. Now, let me show you. I'm coming. So let me show you now. Here, we declared the owner of the smart contract. Yeah, this is it. We declared the owner of the smart contract. And here, we set the smart contract to the person that deployed the smart contract, which is the owner. So we check if the person calling this issue, this function is the owner, is the person that deployed the smart contract. If not, we can basically say unauthorized. You know what I want to write. I'm sorry, that's a mistake. So unauthorized. So since I don't know how to spell it, I'm very sorry. So unauthorized. So if it is the owner that called this token, no problem. So basically, this is a fork function which I know most of us are conversant with. So basically, it is going to go through the stakers array. So what I mean staker, like this just keep tracks of everybody that stakes, right? So it will check for everybody that stakes. Now, array, if you want to like, okay, for you to be able to check, for you to be able to access all elements in an array, you have to like look through everything. So if I want to get access to first element, the array starts from index of 0. That's why I set my stuff to index of 0. So I'm basically going to save the first, sorry, each staker address. But I'm basically, sorry, I'm going to like access this each staker address, which is this. Call the recipient. You can name it. You can name it anything, but it must be type address. Imagine me using int. It will throw an error because address is not a unit. It's not an int. Sorry, it's an address. So then you like stake. So you like save the so you like check the user staking balance. You like check the user staking balance. So this is the recipient now, which is the recipient's address. Then you like check the staking balance, which is called balance. Then you check if the staking balance is still greater than 0. If the staking balance is greater than 0, fine. Transfer money to the transfer anything you want to transfer to the person. If not, the person doesn't get money. So meaning for you to get access to this issue token, you mustn't unstake your token till the person say you should unstake. You can actually, this is just a mini smart contract. You can say before you unstake now, imagine me putting a staking time, sorry, an unstake time. Imagine me trying to call this on stake account and I throw an error that okay, on stake time has not reached. Let's say there's a smart contract that says you should write a staking smart contract that allows user to stake money for 1 month and will be able to stake after that 1 month. By that you cannot stake anytime. So I think we got the little we want to do. So I don't know. I would like to show you guys another thing. Most of you have known it. So let's say for some reasons we want to change the owner of the smart contract, which is called change. Let me change ownership. Ownership. Yeah. So as I've also said earlier, the only person that can call this too, like the message, this thing must not be public to everybody. Yes, it will be public, but you'd give a check. This is the same check we wrote here that we said we check if it is the owner. So let's say you want to change the ownership now. The only person that is allowed to change the owner is the owner of the smart contract itself. So let's say ADDRASS. Let's say we want to pass down the new address of the person that wants to become the new owner. Are you getting it? So you check if the person calling the smart contract is the owner of the smart contracts. If the person is the owner, so you then set the new owner to the address you passed in. So immediately you call this address. You are the owner of the address before. Immediately you call this, so you are the smart contract before. Immediately you call this address and you set the new address to this. Nadia, I'm very sorry. You don't have access to this again because you've been kicked out of the owner. So the person that will call this address now is the new address that will be able to call this function and some other functions, the issue token functions will be the new person you've assigned the ownership to. So what else can we create? Okay, let's do it like this. Let's say you want to increase the total supply of our. Oh, sorry, we can't. This is not a token. I think that should be all. I'm just like thinking of what to let's say another thing to do, but if you don't have anything, you can just like we'll probably have to stop here. So this is not our basic smart contract that we just like make a front end for. Oh, another thing came to my mind, but I think that should be in another tutorial. So let's head down to our front end application. So in this our front end application, we're making use of our React.js. So it's not compulsory for you to make use of React.js. You can actually make use of your pure HTML and your vanilla JS. But I don't know. I just prefer to make use of vanilla JS. You get. So okay, I think I remember what I want to see now. So let's say you don't have a DAI token here. I'm making use of Ganache, which gives us 100 fake ether. So let's say you don't have a token, you don't have the DAI token, you don't have the DAI token that you want to use to stake. You can actually write a function that would allow you to buy token, to buy a DAI token with your ETH, but we're not going to cover that. So let's okay, I think let's stop here. In our next series, we'll be working ourselves to how to like integrate our front end with our Web3.js. So as I've showed you guys earlier, we're making use of Web3.js. If we don't want to make use of Web3.js, there are a couple of libraries too. There's one called Ether.js too. It's used to integrate front end with our ABI. Our API is just like the binary interface that allows our smart contract to communicate with our front end. So that's it. Thanks.